So, in this module we will study about dynamic equilibrium equation using energy method. So, we will discuss about energy principle and then how to derive equation of motion in this module. So, if you look at a simple single degree of freedom system idealized as shown in this figure as a mass and spring system, or you can see that a weight is suspended by a spring. So, what happens is when a weight is suspended by spring, spring elongates due to its self weight. That elongation I am calling it as delta. So, in this graph you can see on the x axis displacement is there, on y axis force is there or load is there, which is represented here. So, on x axis delta is the displacement when load self weight is acting on the system. So, spring is elongating by delta, and at this position where self weight deformation is already there, we are like setting it to vibrate little bit more. So, we are giving some initial displacement and after that it is set to oscillate. So, it may go up and down, up and down, up and down like that. So, that u we are adding here. So, delta plus u, that is this, and the force or resistance required for that is W plus delta W, which is nothing but equal to stiffness multiplied by the total deformations. So, what this is a constant part which is coming from the self weight, and this is a variable part which is given as a initial vibration. Now, when we draw the free body diagram, we need to find out the equilibrium equation using this, but before that we write energy contained in the equation. What is the total energy? Total energy is always equal to the sum of kinetic energy plus potential energy. So, kinetic energy gives the energy which is there in the vibrating part, that is because of the vibration or because of velocity, and potential energy is composed of two terms, that is a strain energy stored in the system and in addition to that work potential. So, how much work has been done in the system. Let us write down these two terms. Kinetic energy. So, kinetic energy is half mv square. Half mv square means half m velocity square. So, since the displacement, if I write the total displacement is delta plus u. So, if I differentiate this with respect to time, I get only u dot. So, kinetic energy is half m u dot square. This is kinetic energy. And now, let us write potential energy. So, potential energy here consists of say two terms, that is strain energy minus work potential. So, how much work has been done by the body by pulling from like a static equilibrium position to the u position, that is W into u. So, if we open this up, if I show you, yeah, so this is strain energy stored in the system minus half delta square, this portion is the energy in the vibrating system minus work potential. So, if we rearrange these terms, we get half k delta square plus half k u square plus k delta multiplied by u minus half k delta square minus W into u. So, that will give us the value. You can see this half k delta square will get cancelled and k delta is W. You can see this one, this term, this k delta is W. So, that is W into u term will also get cancelled. So, finally, we are left with half k u square. So, half k u square is a potential energy term and half m u dot square is a kinetic energy term. So, the total energy is like potential energy plus kinetic energy dot, okay, half k u square plus half m u dot square, potential energy plus kinetic energy. Now, we need equation of motion. So, how this equation of motion can be derived is like this, potential energy, the total energy is always constant. So, for energy to be minimum, let us take the derivative of this total energy with respect to time and equate it to 0. So, if we do that differentiation, half m, so u dot square is there, so that term will get converted into 2 u dot into u double dot, because another one more time differentiation, and half k u dot u square will become 2 u into again u dot, that is equal to 0. So, if we take the velocity term common and half term, because on the other side it is 0, so we will get this. So, m u double dot plus k u like multiplied by whole multiplied by u dot. So, u dot is cannot be 0 for non-trivial solution, for real conditions u dot cannot be 0, then this equation, that is mu double dot plus ku will be 0. So, that is equation of motion using energy principle. So, we have derived it using energy principle. So, this is similar to equation of motion for undamped free vibration. So, in summary, what we have discussed in this module is, like, we have tried to formulate equation of motion using energy principle. So, in energy principle, we have taken spring and then we have attached a weight to that spring. So, because of attachment of weight to a spring got elongated, which the reaction is equal to the weight of the body, and then we gave initial displacement to that and then calculated the total energy of the system. The total energy of the system is equal to kinetic energy plus potential energy. This total energy will always be constant. So, kinetic energy is related to velocity of the system and potential energy related to strain energy and work potential of the system. So, after getting the total energy, and we already know that this total energy will always be constant, we have differentiated it and equated the term to 0. So, for minimum energy, first derivative of the equation should be equal to 0. We got the equation of motion, which is similar to equation of motion for undamped free vibration.